Greetings. Now today we're going to look at the effect of electromagnetism, where I have a magnetic bar, and I'm going to use this magnetic bar to show how current is induced in this particular coil. And the current or the induced EMF will be detected by this voltmeter, and the voltmeter that we have is able to detect both positive and negative. Okay, let's say now I begin to move the magnetic bar in and out of the coil. Take notice of the needle on the voltmeter. You can see that as I move in, the voltmeter, the needle is start to swing from left to right. Yeah. All right. So what's happening here is that as you can notice, there is electrons in the coil, and these electrons, the moment I move the magnetic bar, the electrons also start to move. And from the definition of current, which is rate of flow of charge, when these electrons move in the coil, you have induced current or induced voltage. Okay, that's now I replace the voltmeter with a bulb. Okay, and to see the effect, you can see that the moment I move in and out of the coil, the bulb illuminates. Alright, now what if, let's say, I place the magnetic bar in the coil but I do not move it? Okay, so you will notice that there is no effect. Okay, the reason being because there is according to the law of Faraday's law of electromagnetism, there should be um, rate of change of magnetic field. Okay, so meaning that the magnetic flux around the magnetic bar need to cut uh, when you move in the coil, meaning that there must be a change in the flux. Okay, so since there is no change in the flux, there's not going to be any EMF induced. Okay, see, for example, here I can replace with a voltmeter, and I can do the same, and you'll notice that once I place it in, there's no change in the movement of the needle. Okay, and you know that if we increase the number of loops, the magnitude of the, say now I change from 2 to 4, double up. Sorry, okay, right, so maximum is 3. So when I move it, you will notice that now the reading is much more higher. Okay, so you notice that the reason being because when you increase the number of loops, you're also increasing the number of electrons. So the number of electrons correspond to the higher current, thus higher voltage. Okay, thank you.